Hi, welcome back. Today I'm here with a topic that would be beneficial for parents who have kids in the lower classes. Obviously, parents are in trouble to make children understand the basis of mathematics. I think that's a universal problem. Those kids who were playing, suddenly when they were going to school and coming with the mathematics, they might get struck. So I think this video might be beneficial for more the parents who struggle to make their children understand, at the same time for those students who struggle to understand the basis of mathematics. It's nothing other than the Singapore math. In this video, I'm letting you know what is Singapore math and what is the peculiarities of the Singapore math that make the students in Singapore to be the toppers of all the international tests in math and science. So coming to the two main international tests, that is the TIMSS and the PISA, assess math and science competency among various countries across the world. TIMSS is a Trends in International Mathematics and Science Study, collects data from students of grade 4 and grade 8 since the year 1995, and it is conducted every 4 years. And the latest one, which was done in 2015, that was for students of grades 4, 8 and 12. TIMSS also measures advanced mathematics and physics achievement in the final year of the secondary school across countries. Coming to PISA, which is the Program for International Student Assessment, measures a 15-year-old student reading, mathematics and science literacy, and it is conducted every 3 years since the year 2000. And it also measures the general or the cross-curricular competencies such as the collaborative problem solving, and it emphasizes functional skills that students have acquired as they near the end of the compulsory schooling. And the recent one which was done was in 2018, and the results are out a few days back. And all these test results prove that the Singapore students are among the toppers in mathematics. Now let's see what Singapore math. Actually, there is nothing as Singapore math. It is a name given to an effective teaching approach which was originally developed in Singapore by the Singapore's Ministry of Education for the public schools. And recently, while adopting that to the other countries named it as the Singapore math. Before going in detail to the Singapore math, let's see to the other math systems. The drawbacks of the other math systems are they are too fast, having too many halls, make the students struggle, saying that they cannot do it. As you all know, the traditional math systems, they are too fast. It means that the teacher have to cover X amount of topic within a limited time. So obviously she have to go fast. Maybe some of the students might not understand the meaning of the concept, and this make them lag behind. But in this situation, each and every student is not given an equal opportunity to understand the concepts. And that creates too many halls, and that system creates trouble to the students. But if you consider the Singapore math, it is too slow. That is, it gives the student equal opportunity for understanding the basic concept, and only a limited amount of topics is being covered in a time frame. But whatever the topics being covered, even though it's very small, each and every student of the class understands it very well, and though that understanding remains within them forever. So now let's see in detail the Singapore strategy. According to the Singapore method, they spend more time building the foundation of mathematics. As we all know, building a home means it needs a strong base or a foundation. Likewise, to study a subject, you need a strong base, especially in case of a subject like mathematics. So you have to spend more time building upon the foundation. And the key features include CPA, number bonds, bar modeling, mental math, etc. Among all these, the most important feature is the CPA approach. It's called the Concrete Pictorial Abstract Approach. That was developed by an American psychologist Jerome Bruner. It was in the 1960s. And the CPA approach develops a deep understanding of math through building an existing understanding. That is, when a child is sent to school, the only things that he is familiar might be his toys, like the blocks, dice, or even some sticks, like matchsticks, or sometimes something from the kitchen, like the peas or beans. All this we can utilize for making him deeply understand the concept of mathematics. The first part of the CP approach is the concrete phase or the doing stage, where the student themselves interact with the physical objects to model problems, where the teachers will lead the activity engaging the students themselves. That is, the teachers or the parents, they can involve student interactions by providing them with some concrete objects which they can count or they can easily judge. Let's begin the CP approach in detail by starting from the concrete. So concrete method means something concrete objects the child should take in their hand and feel it and be able to count it. For example, it can be some blocks or dice or maybe some paper pins or even some beads, or even you can use some of the beans from your kitchen. So now let me start with the blocks. So I have a question that is 4 plus 3. So to understand the 4 plus 3, I have to have two units. That is a unit of 4 blocks and a unit of 3 blocks, which the child should be able to count. So this is the unit of 4 block, 1, 2, 3, 4. And I have another unit of 3 blocks, that is 1, 2, 3. Now the next step, that is 4 plus 3. 4 plus 3 is addition. It means adding up. So adding up means joining together. So joining together, child should be able to count and feel with his hand. 1, 2, 3, 4, 5, 6, 7. So 4 plus 3, answer is 7. So you can understand from this, that is, by using the concrete method, we are finding something abstract. Next comes the subtraction. Subtraction, let's consider 7 minus 3. So let's take a group of 7 blocks. So I took a group of 7 blocks. You can count it. Make the child to count it first. 1, 2, 3, 4, 5, 6, 7. Okay, now there is a 7 block. From that, you have to take off 3. Minus 3 means take off. Okay, give away. So you're going to give away 3. So 1, 2, 3. You're going to get giveaway. So whatever the left behind, that's the answer. So 1, 2, 3, 4. So with no doubt, the child can find the answer to be 4. So coming to multiplication. Multiplication, that is 2 into 3. So 2 into 3 means first make the child aware of what is multiplication. Multiplication means a repetition. So repetition. So first 2 into 3 means 2 is repeated 3 times. So the child know the patterns, the repetitions and all. So 2 is repeated 3 times. So make him understand that take 2 blocks at a time. So one time he took 2 blocks. How many times he need to take it? 3 times. So another set of 2 blocks and another set of 2 blocks. So 3 set of 2 blocks. Then ask them to join together. So when they join together and count 1, 2, 3, 4, 5, 6, got the answer 6. So 2 into 3 is 6. Coming to division. Division, you can let the child, like a question mean 8 divided by 4. Okay, 8 divided by 4. So first make the child understand what is division. Division means dividing or partitioning an object into a particular size. So partitioning the object, which object are we partitioning? That is, in this particular case, 8 divided by 4. 8 is the object. So you have to take 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8. So you took 8 blocks divided by 4. What is that? You have to divide 8 in 4 blocks. You have 8 blocks. You have to divide it into groups of 4 blocks. So you have to count 1, 2, 3, 4. So 4 blocks. You have to split it out. So now you know how many pieces are left now. The 8, the group 8 is being split into 2 groups. That is 1 and 2. So the answer is 2. So if you divide a group of 8 and split into 4, then the number what you get is 2. So 8 divided by 4 is 2.
Pictorial phase is also called seeing phase, where they make mental connection between the objects they have just handled and visual representation of those objects. That is, the student has handled some of the objects in the concrete phase, and in the pictorial phase what is seen is those objects are made into pictures. For example, if you see some real apples or if you see some real objects in the concrete phase, they are made into pictures in the pictorial phase.
First, we came across the concrete method. Next, we are going to the pictorial method of CP approach. So the pictorial method can be different types. Either it can be a bar diagram or a number line. So coming to bar diagram, let's consider the example 4 plus 3. So as you represent the graph, you can just draw a bar diagram like this. So groups of 4, 1, 2, 3, 4, that represents this 4, and 1, 2, 3, this 3. So you have to write like this or draw like this, and then you have to join it together and count it 1, 2, 3, 4, 5, 6, 7. So answer is 7. You can see that considering the previous concrete method, the pictorial method is just a picturized representation of the concrete method. There in the concrete method, you could feel the object, but in the pictorial method, there is no object to be felt. Instead, you could see or visually feel the presence of the object in terms of diagrams or pictures. For example, in the concrete method, if you are taking an apple, in the pictorial method, you will be drawing the picture of an apple. So that's the difference between a concrete method and a pictorial method. The same 4 plus 3. If you represent it in a number line, so that's a 4 plus, this is a number line, And 4 plus 3, let's consider that. Okay, 1, 2, 3, and 4. That's a 4. 4 again plus 3. So you have to have another 3 more. So 1, 2, 3. That's the total. What is the answer you're getting? So this is the answer. So 4 plus 3 is 7. Mostly these type of pictorial representation and concrete representation that would be beneficial for the kids up to the 5th grade, because they'll be dealing with the smaller numbers. But when you go to larger numbers, you cannot represent that in either bar diagram or number line, or not even in the concrete method. Then you have to go for the abstract method. So actually this concrete method and the pictorial method, they aim to be a forerunners for the abstract method, for the children to understand more quickly the problems. So this is how you can represent multiplication in pictorial method. That is 2 into 4. So 2 into 4 means it's a repetition of 2 blocks of 4 times. So it's represented as 1, 2. 2 is repeated. This is 1 time, 2 times, 3 times, and 4 times. Okay, so the total, you have to add it up. Everything you have to add it up and find what is the answer. So 1, 2, 3, 4, 5, 6, 7, and 8. So the answer is 8. Isn't it easy? So coming to the number line, same way, 2 into 4. So in terms of 2, 1, 2. 2 is a unit of 2 is repeated 4 times. So this is 1 unit of 2. Again 1, 2. Again one more 2 is there. Again one more 2 comes. 2. Again another 2. Okay. So 1, 2, 3, 4. 4 times 2 is repeated. The answer is 8. Coming to division. A simple division by a single fraction, that is 6 divided by 2. So you have to draw 6 blocks divided by 2. You have to split in 2. 1, 2. This is 2. Again 1, 2. And 1, 2. So how many times you are dividing? In terms of 2. 6 is divided in terms of 2. So one time you divided 6 in terms of 2. The second time. And the third time. So 1, 2, 3. So the answer is 3. 6 divided by 2 is 3. If it is in number line, the same way, you take 6 in number line. Then starting from here, 6 is divided. So first 2. 2 units. 1, 2. 2 units. Next 2 units. 1, 2. And the next 2 units. So total 1, 2, and 3. 3 units. So the answer is 3. So coming to fraction. 6 divided by 1 by 2. So here you should understand that each of this block, this is considered to be 1. Okay. And if this is 1, half of this is 1 by 2. Isn't it? 1 divided by 2. That is, the whole 1 is split into 2 parts. So 1 divided by 2, half. So it has 2 parts. So 1 can be divided into 2 parts. That is half. So the question is 6 divided by half. It means that how many times you can divide 6 in terms of half. Okay. So the whole thing you have to divide in half. And count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the answer is 12. 6 divided by 1 by 2 is 12. You know that, no? So 6 into 2 by 1. The same abstract method, if you do like this, the same answer we are going to get. So considering little more complicated fractions like 2 by 3, 3 by 4, etc., where for I don't think so multiple fractions will go for kids. So let's consider 4 divided by 2 by 3. 4 divided by 2 by 3 means here the child should be able to understand what is a fraction. 2 by 3 means if a single block, if you consider, it is divided into 3 parts. The denominator you have to consider, that is the number of parts. That is, it is divided into 3 parts. 2 by 3 is divided, 2 by 3 means it has 3 parts. A single block has 3 parts, 1, 2, 3. 2 by 3. 2 by 3 means the 2 parts of 3. Okay, this is what a fraction means. If child is aware of this, then they can do this problem. That is 4 divided by 2 by 3. 4 divided by 2 by 3 means there are already 4 units, 4 blocks. Okay, and 4 blocks I have drawn here. Divided by 2 by 3. So 3. 3 means you have to divide a single block into 3 units. Okay, so I'm dividing a single one into 3 units. See, 1, 2, 3. 1, 2, 3. 3 units. Now, the question is 2 by 3. 2 by 3 means 2 parts. So this much part. Got it? So this much part I'm taking. So now the question is 4 divided by 2 by 3. 4 divided by 2 by 3 means for how many times you can divide 4 in terms of 2 by 3. So one time like this, 1. Again consider this is another 2 by 3. Then another 2 by 3. This is another 2 by 3. So now count how many number of 2 by 3 you got. 1, 2, 3, 4, 5, 6. 6. So the answer is 6. So 4 divided by 2 by 3 is 6. Now let's check it out in the abstract method. That is 4 into 3 by 2. Let's go 12 by 2. Let's go 6. So the answer is 6. Last phase is the abstract phase or the symbolic phase, where the students use symbolic modeling of problems using numbers and math symbols. Here, the students are shown an equation like using symbols like the multiplication, subtraction, division, or addition symbols. With the real numbers and the symbols, they find the answer. Number bonds are a pictorial technique that shows the part-whole relationship between numbers. Initially, the whole number is written in a circle and the parts of the number are written in adjoining circles connected by lines to the first circle. It fosters a solid number sense that serves students throughout their math education. And this is helpful in the elementary schools to work towards addition, subtraction, and to solve the expressions mentally. So basically, this is a connection between the numbers. Before going to number bonding, let's consider moving from concrete to number bonds. So here are 5 blocks. So if you ask a student to divide this 5 blocks into 2 parts, they can either divide it in 1 and 4, or they can divide it as like this way, 4, 1. Again, they can divide it as 3 and 2, or 2 and 3, or they can divide it as 5 and 0. So all these shows the connection between the numbers. It can be represented in the number bonds like 5. 5, that is the whole number, you have to circle it, and it can be split in different forms. One is 0 and 5. Next method, where you can split it in 3 and 2. The other method, you can split it in 2 and 3. In another method, you can split in 1 and 4. The other way, you can split it in 4 and 1. So these all shows the connection between the numbers. By using this number bond technique, it would be easy for the children to find out the missing numbers in the addition and the subtraction methods. For example, consider the number 4. So, the 4 can be split to 2 parts. So, if 3 is one part, what is the next part? The child can easily understand. Similarly, if the whole number is missing and the small numbers is known, like in this case 3 and 3 is known, so the whole number can be found.
Tutorial technique itself, we have come across this bar modeling, and it is a powerful tool where a range of math concepts such as the fractions, ratios, percentages, and much more can be represented. And it is also a part of the CPA approach. After following all these methods, the final procedure is the mental math, where the mental strategies involve decomposing number into parts, then performing operations on them in different order from the original expression.
Hope you liked the video. If you would like to see more videos like this, please subscribe and please like, share, and extend your valuable comments.